All right, so welcome to the Idaho Orenco AdvanTex AXMAX presentation. This is going to cover the implementation and applications of this particular product in the state of Idaho specifically. We've got a few projects here we'd like to talk to you about. Hopefully this will be informational. This presentation was developed and presented by Orenco Systems Inc. and RC Worsting Company combination. So basically, what is Advantix? If we digress a little bit, ultimately we're looking at a treatment technology that's a textile-based packed bed attached growth system, roughly patterned after recirculating gravel filter technology or even intermittent sand filter technology that's been around for a number of years. The beautiful thing about Advantix and the textile and the packed bed nature of the design is that it's very passive, so you end up with a kind of a progressive treatment or passive treatment in where you have wastewater that's stored in a container and dosed over the media a number of times, and so you get kind of a dilution and a push of forward flow after treatment. So the nice thing about it, of course, is if it's or when it's time dosed over the treatment, you get surge flows that come in, then those ultimately get held up in the tank and are, appropriately apportioned into the media, and so those surge flows really don't have a problem with the system specifically. We're primarily discharging from the Advantix system into soil-based disposal systems, either smaller than large soil absorption systems or larger in some cases, flows up to 50,000 gallons per day. Currently, we're working on a couple projects in Idaho that are up in the 20,000 gallon per day range. The applications include, as you can imagine, rest stops, schools, subdivisions. We've got one that's basically a steel manufacturing plant, a beef kill plant we're working on right now down in southern Idaho. So there's a lot of different options for this if the facility is not on or close to city sewer services. The origins of Advantix, we talked about this a little bit before, or I talked about this a little bit before in regards to recirculating gravel filters and intermittent sand filters. Orenco, way back in probably the 90s, and even before that, had been using that technology quite a bit in their recommendations and ultimately decided to pioneer another way to perform that type of treatment, the passive packed bed treatment. So instead of using gravel or sand, they're using a textile that has a lot more surface area, so it's compressed and ultimately ends up in a lot smaller footprint. They started with the AX20, and so basically this is more of a residential system, 20 square foot textile, 500 gallons per day. And so that's a loading rate of 25 gallons per square foot per day to come up with that 500 gallons per day. The AX100 is 100 square feet. That was more the commercial system. Each pod would handle about 2,500 gallons per day, depending on, of course, how it's loaded. The AX20RT, they were able to incorporate a tank into that, and they were able to put in 20 or 25 square foot of media. So that extended the range of one individual residential system up to 625 gallons per day with the AX25RT. And that is kind of a nice system in that you've got all the pumping equipment under one lid, like you'll see with the AXMAX unit, which is a pretty recent arrival on the scene for Orenco. The AXMAX is up to 300 square feet per unit, 42-foot long piece you see there. They bought a Bayliner plant down in Oregon that was, I guess, defunct at the time, and they're doing fiberglass work. These are all prefab fiberglass units, insulated to R26, I believe. So the AXMAX unit is designed to handle 7,500 gallons per day each at the max size. Of course, they have a variety of lengths and media sizes built into these, as you'll see here in a little bit. So one of the projects we did recently with Orenco and an engineer out of Lewiston. This is down in Chalice, Idaho. It's called Living Waters Ranch. And what they basically had was kind of a Christian retreat ranch where they had all kinds of different activities that people would participate in. They had very, very variable flows. In a lot of cases, they'd have people coming in on weekends, big groups. They have a church structure. They have a bunch of living quarters, a couple homes out there where some of the staff live. Shop. It's all connected to this through step collection. There is one facility that has a grease trap on it. And it ultimately makes its way down to, in this case, a pre-anoxic tank. And I'll show you the configuration here in just a little bit. But the design flow for this system is approximately 9,000 gallons per day. The peak flow, could be as high as 11. We calculated the influent waste strength at 200 milligrams per liter BOD, 60 milligrams per liter total suspended solids, and 65 milligrams per liter total Keldol nitrogen, or TKN. Now that's 65 is not entirely high for this kind of waste. In some cases we see higher than that. Of course, Idaho DEQ for estimating residential influent calculates at about 45, which probably isn't entirely accurate from a design perspective, because normally it's quite a bit higher than that, even on residential strength we find. So ultimately, through weekly testing in 2014, they came up with 11 milligrams per liter BOD on average, 5 milligrams per milligram per liter TSS, and 10 milligram per liter TN. And some of the total nitrogen numbers were down below 5. This particular system in its configuration is interesting from a standpoint that we were able to incorporate a lot of the controls that we have with Advantix. And so ultimately we've got the effluent coming in from the septic tanks, and ultimately, as I said, there's a step collection on each facility, so gravity flow down into the system. It comes into what we call a pre-anoxic tank, where we're injecting some alkalinity from the alkalinity feed system into the front end of the pre-anoxic tank to ensure that we're able to nitrify the effluent in the AXMAX units, in the aeration portion of the system, or the aerobic treatment portion of the system. So from there, the pre-anoxic tank, which is basically up here in the picture, the wastewater flows into the first AXMAX system. These are commonly connected. So you got a pipe that moves across to the second AXMAX system. Ultimately, that's where the pumping equipment is located. And so that pumping equipment doses over the top of each unit. There's also pumping equipment in the same location that doses out to the pre-anoxic tank and the post-anoxic tank for discharge. So the post-anoxic tank is actually connected to the discharge chamber. So you have an amount of wastewater that goes over the top of each unit, and eventually it makes its way to the discharge tank, or the dose tank, to the discharge system. There it gets dosed essentially through the chem feed building, picks up some carbon. So when that pump's running, the carbon pump is also running to inject carbon, so we can drive the post-anoxic tank anaerobic or anoxic to ensure we got good denitrification there. And that's kind of a balancing act, because as you guys probably know, if you inject too much carbon, that adds BOD to the waste, which is the whole point of injecting carbon. And to drive this anoxic, if you add too much carbon, you can send your BOD through the roof in your testing. You might be getting good denitrification, but ultimately you could be out on the BOD parameter. So that's a careful thing that you have to consider. And in this case, we have these variable flows that I mentioned, and the operator, who is really diligent, his name's Corey Rice, is doing a very good job of anticipating those flows and making adjustments accordingly. We don't have this specifically set up to anticipate incoming flow, which would be difficult but possible in some arrangements that are up and coming. So ultimately then we discharge out of this discharge chamber. There's one pump that pumps to a dose tank on one particular drain field area, and another pump out to another particular drain field area. So that's this system in a nutshell. The AXMAX unit itself looks basically like this in a cutaway, and so the way they function is you have incoming flow from the septic tank system. And so this would be basically be septic tank effluent coming in, and this pump chamber over here is common connected to the recirc blend chamber, which is this chamber here as well. So these pumps are what drive the wastewater over the top of the media. So when that pump comes on a time dose basis, of course, X number of times per day, it sprays over the top of the textile media. That wastewater falls through the media and is treated, and eventually falls either into the recirc blend tank to dilute that wastewater, improve the quality of it there, or it actually falls into the dose tank. And so it just continually does that. Eventually the dose tank section fills up to a point that activates a float that or a timer, depending on how we're dosing out, that'll dose the wastewater out to the drain field. In its simplicity, of course, there's more complex ways to deal with that with the pre-anoxic and post-anoxic tanks. We can recirculate back to those accordingly from that location. So that's basically in a nutshell. If you don't have any forward flow, so if water's coming in and you have no water going out, as you can imagine, as the water falls through into this dose tank liquid level will rise to a point that exceeds the recirc blend tank liquid level, and then the pumps will come on and it'll pull that down. Pretty soon you'll pull this liquid level down and eventually dose this out of water if you don't have a way to balance that. So they have a little valve, and it's not shown in this image, that allows water to drop back through when this dose tank gets to a certain level and this tank is below a certain level. So it's kind of a balancing deal. So the important part to understand in regards to that valve is when you have periods, let's say, during the evening or at night, or later in the evening at night, or even during the day, if you don't have periods of high flows, then basically the wastewater ends up just recirculating over the media. Some of it drops in the recirc blend tank, some of it drops into the dose tank, but all of it ultimately ends up back in the recirc blend tank, or almost all of it, depending on if there's any forward flow at all. If there is any forward flow, that gets pushed out to the drain field after going through that process. So again, as you can imagine, this is sized so you end up with typically a 4-to-1 or 5-to-1 ratio before the wastewater goes out. So every bit of water goes through here a number of times, and in some cases multiple times before you see issues, or before you see the discharge pump come on and send it to the drain field. So on average, we end up with a very highly treated effluent, as shown in the Living Waters Ranch illustration. So our loading rates to the media vary hydraulically, and this is how we typically size everything. Is hydraulically we can load this media at 25 gallons per square foot per day, every day on average, all the time. If we have surge events that are temporary, we can load that all the way up to 50 gallons per square foot per day. And we'll talk about the DEQ's dual train requirements here briefly in a moment, but that kind of helps us meet that requirement because we have some surge flow built into just the media loading rates. The organic or the BOD loading rates, obviously we would want to go back and calculate all of this based on what our influent BOD is predicted to be. So that's 0.04 pounds per square foot per day average, 0.08 pounds. And so if we've got a consistent residential strength BOD, that matches fairly closely to the 25 and 50 that are the hydraulic loading rates. And this is the one that catches us in design sometimes, the nutrient loading rates, the TKN loading rates. So this is the nitrification portion of what the system's doing for us. It has to be loaded at 0.014 pounds per day per square foot, or 0.028 pounds per day per square foot of TKN. And in a lot of cases, if we have a facility that has a lot of toilets and not a lot of showers, or no showers, ultimately that TKN is going to be way higher than it would be in a residential project. And so we have to look at that TKN loading rate, and in some cases it drives the size of the treatment system larger than the hydraulic loading rate sizing. So some people have questioned our sizing, and in some cases we have to show them that the TKN loading rates, based on the nitrogen reduction they're looking to get, we have to actually add more media to that application. So normally we get a BOD TSS reduction of 95%. Coming out the end is usually less than 10. BOD TSS. The TKN conversion to NO3 is nitrate is usually 95%. Total nitrogen reduction is 60 to 70%, but can be higher with the pre and post anoxic and chem feed systems. There's also a couple other systems on the market that we can add to it to improve the denitrification process to get a better TN number out the discharge end if we need to. So dual train redundancy. One of the things that DEQ requires under IDAPA is the dual train redundancy, and it's specific to private systems, but there's also a dual train discussion on, some of the public systems as well. Ultimately, we had a meeting with Barry Burnell and Tyler Fortunati with DEQ on this specifically last year. In these discussions, we talked to them a little bit about how we're loading this and how we have reserve capacity for loading. What they really wanted to see from a redundancy perspective is redundant pumps, redundant blowers, and we have some form of zone isolation. So in this picture, we can actually zone this system off, from left to right here in the photograph. There's this system doesn't specifically have it, but we can put valves on these supply manifolds and zone one section of the media off if we need to address an issue. Quite frankly, it's not entirely practical to zone it off this way, just because if you were to pull sheets, you would need to just shut the whole thing down and pull sheets and either clean them or replace them. It's a pretty short temporary situation, and during a cleaning or repair, you would have enough reserve capacity in the tankage to handle the flow, so it wouldn't be, a major upset or issue ultimately if you had to shut the system down for a few hours. But DEQ wanted to see some redundancy, so we had to show them that we could shut down part of the system if needed. So primary tankage or even process tankage, before any Advantix system, any pack bed filter, you have to get your waste strength down to essentially, residential strength effluent, septic tank effluent. And so in order to do that, we're putting tankage in front of it through either step collection or primary retention. In this case, we've got a project down in Caldwell, Idaho. This is a big Xerxes fiberglass tank. It happens to be an 8,000 gallon that's set in front of the Advantix system. And they've got some valving in front of that to accept flows from a couple lift stations they've got on site. We can also use this kind of tankage as pre-aeration. So if we have a high strength waste that comes in that we need to drop it down to the residential strength that Advantix can accept, we can install a pre-aeration tank in front of the primary tank or in place of the primary tank. We also, in some cases, as part of the primary tank, turn a section of that into a pre-anoxic tank. So we have some baffling in there, and then we have some, in some cases, some chem feed into that pre-anoxic tank in order to reduce nitrogen at that point. That's recirced back to that location. And again, ultimately in the primary tank, you have an anoxic zone. So when you recirculate the nitrified effluent back to that location, you have the ability to denitrify that, and that's the whole point of the nitrogen process there. Post-anoxic process, of course, as I said, that sometimes is in combination with your dose tank system. We can do the same thing there, whereas if a little nitrogen from the process gets moved out to the discharge system, we can add some chemical feed or drive that anoxic in some way with some BOD in order to denitrify at that place. So that's kind of a polishing denitrification location that can get us down to really low numbers if we decide to do the denite there. One of the beautiful things about the AXMAX package that I discovered early on when we started putting these together was that they're very compact. They're pre-assembled at the factory, so ultimately they come exactly as you see this one in the picture. The lids are battened down, the thing shows up on a truck. They unload it, they set it in the ground, all the pumps are installed, the blowers are installed. There's really no assembly other than pipe and wire. And so from a construction perspective, these systems are very easy, and you don't have to rely on a contractor to have special training in order to get these things in correctly. It's pretty dang simple to do a design with one for one thing and install one for another. Orenco on these designs provides a full set of drawings on their equipment specific to the projects, and they're pretty good at turning those around quickly. So we have our piping penetrations all set from the factory. In this case, we have the conduit LBs here, so the electrician can just bring that stuff in. You can't see them, those splice boxes on the inside where they're going to run their pump and float cords to. This particular tank did not have them, but we can provide anti-buoyancy flanges in areas of high groundwater, so that's another option for these systems. From an operation and maintenance perspective, we have a really nice setup here to provide access with a hydraulically assisted lid over all of the equipment. As you can see, the pumps are all set in there. They're all high head effluent pumps, basically fairly lightweight. A guy could reach in there. They're not on guide rails. You could reach in there, undo the, shut the valve, undo the union, and pull the pump out by hand easy enough without much trouble. Of course, cable disconnection just comes out of that splice box, and you can undo the cord grip to pull the pump out and replace it or clean it or whatever you've got to do. And so that's pretty easy. The float trees all have, or the float tree in this case has a handle. You can just pop that out and access the floats if you need to. The telemetry controls that come with these, the VCOM system, you can get that with a pretty simple setup. Ultimately, though, it can be accessed through an Ethernet or phone line, dedicated phone line, and so that can send out alerts and alarms to the operators, owners, engineers, whoever wants to be involved in that process. And of course, they can upscale that panel itself to include a touchscreen display. And the nice thing about that touchscreen display is the on-site operator has full access to all the parameters in the system without connecting through the remote monitoring or some kind of, computer-based cable connection. Some of the additional options that we offer through Orenco, and some of them we offer that's just exclusively offered by RC Worsting Company, is, Orenco does have a pre-manufactured control shelter. As you can see in that picture, this is again the Living Waters Ranch project, and that control shelter was part of that project. They poured a base for that, and we put that down, and that's got the chem feed and electrical controls in there, and it's it's an insulated, environmentally controlled building. We have some pre-packaged lift stations that we offer as RC Worsting Company. So on the project down in Caldwell that I showed you in the, I believe, the previous slide, that lift station is built and provided by us, and so those can be a variety of configurations. And we can do solids lift stations, and we can also do effluent dosing lift stations if we have to dose out to the drain field. And then the other thing is, if we have to get sophisticated with treatment levels, then we can provide other stages, other parts of the process. I mentioned a little bit about aeration, but there's other things we can do in order to improve treatment quality if required. So essentially that's the presentation. RC Worsting Company and Orenco are fully capable of providing any process guidance. Orenco provides a design criteria document, which we can certainly walk you through and help you with in terms of applying the technology. That design criteria document obviously provides some really quality calculations and support for applying the product, and we can do plans review. We can even do, in some cases, some plans preparation and engineering if that's something that you need. We try to stay out of that just to try to not step on anybody's toes, but that is something available to you if you're looking for some help on these things. So thank you very much for watching this presentation, and if you have any questions, give us a call.